is Ashim Sattar from the Indian Institute of Technology. Thank you for staying up late, Ashim, to present your.
Thank you. Well, is my screen visible?
Yes.
Okay. Thanks for inviting me for this very important event. I will be mostly speaking on glacier-related hazards and risk and the way forward in GLOF research. This work, it's basically work done with my collaborators from different parts of the world, and I also thank them for their contributions. Well, we have been all talking about this global warming, 1.5 degree anomaly when you try to compare with the pre-industrial times. So what's happening in the high mountain glaciers, if you look into some of the recent research and some of the benchmark glaciers in the Himalayas, if you see this paper in Science, you see that most of these benchmark glaciers in the Eastern Himalaya, Central Himalaya, Western Himalaya have been showing a cumulative length reduction, which means they're losing mass. And if you look into the mass balance here, paper published in 2020, you see a lot of negative mass balance along the Himalaya. Here you can see the Eastern Himalaya, the Central Himalaya, and the Western Himalaya parts, except for parts in Karakoram where you see glaciers, few glaciers showing positive mass balance, but majority of the glaciers have been showing negative mass balance, which means that there has been significant reduction in the stored fresh water. So also looking into what's been happening to the extreme events. If you look into the extreme events from 1960s, if you're looking into the rainfall events to 2020, we have been seeing a sharp rise in the number of extreme events, and a few of these important events listed. The 2013 Kedarnath event, which was a cascade that led to a cascade of glacial lake outburst flood, debris flow that actually impacted the Kedarnath settlement. Well, the most importantly is the question that why are the high mountains more sensitive to climate change? Well, if you look into the entire Himalayan Karakoram mountain ranges, you see that they're very scenic and beautiful, with over 50 mountain peaks exceeding over 7,200 meters above mean sea level. Well, what's important is to look into that, this concept of elevation-dependent warming. On the right top, you can see the temperature anomaly of the mainland India and the Himalayas. Here, you see that the temperature anomalies are higher in the mountains compared to the mainland plains in India. Well, there can be multiple factors, but one of the very interesting factors are that the incoming solar radiation are exposed. The glaciers, the top peaks are exposed to the incoming solar radiation, and the clouds, they block the incoming solar radiation to reach the lower parts. So I think this basically is more exposed, and that is what we see is an elevation-dependent warming effect in the Himalayas. Well, climate change is playing an important role when it comes to hazards and risks, not only in the Himalayas, but all over the world. What do we have is they can be broadly classified into short-term hazards and long-term hazards. And if you look into these, they can be glacial lake outburst floods, ice and rock avalanches, glacier surges, calving, debris flows or hyperconcentrated flows, and cloudburst cascades. These are normally short-term hazards because they can cause impact in a very short duration of time, whereas in long-term hazards, we have sea level rise, permafrost degradation and water security, which can have its impact in a longer time scale. When we talk about hazards and risks, we all know that quantifying risk is complicated, and we need to have data of hazards, vulnerability, and exposure to quantify risk, which I'll be talking in my subsequent slides. Well, what we have witnessed in the recent past is I'm highlighting a few recent events. One of the major devastating events in 2013 is the Kedarnath disaster, which was because of rainfall cascades and led to the outburst of the Chorabari Lake and had impacted the entire Kedarnath settlement here. In 2016, we had witnessed a transboundary glacial lake outburst flood that originated in China, but had an impact in Nepal as well. That triggered numerous landslides along its way. And then we have the Chamoli disaster. That was a rock ice avalanche that impacted 2 hydropower stations in Uttarakhand. Most recently, what we have witnessed is the 2023 October 4th Sikkim floods that originated from a glacial lake in Sikkim, which is called the South Lonak Lake, that destructed the hydropower, Tista 3 hydropower, which was located 68 kilometers downstream of the lake, leading to severe devastation in the downstream region. What's important is that if you look into this pyramid, what is the controlling factor is the atmospheric drivers. That's the precipitation and the temperature that's leading to the changes in the mountain cryosphere, which includes the glacier, permafrost, snow cover, river ice, and that's kind of leading to these hazards. And most importantly, when these hazards intersect with the exposure or the population or community or infrastructure, which are vulnerable, leads to the glacier-related risk. If you look into the distribution of the permafrost, this is where we can see that 1/3 of the land area in the northern hemisphere is covered by permafrost. These are perennial frozen ground that's quite a bit affected by global warming. This is a positive feedback loop that leads to increasing permafrost degradation leads to release of the methane and the carbon dioxide that is released to the atmosphere, and then that the entire cycle leads to increased global warming with time. And if you look closely into the Himalayas here and the Tibetan Plateau, we see a major part being covered by permafrost. The major questions are, why should we be concerned? The facts that there's an increase in the number of glacial lakes, there's increased frequency of glacial lake outburst floods, there's increased frequency of number of ice and rock avalanches, extreme precipitation events are leading to cascading floods. We have seen debris flows and hyperconcentrated flows, and thawing of permafrost is leading to slope degradation and destabilization. All of these events have been directly or indirectly impacting population and infrastructure. And yes, of course, with rise in the global temperatures and degradation of these slopes are going to threaten the mountain communities in the coming days. Another recent study showed the rapid worldwide glacial lake number of glacial lakes. If you look into the numbers, they're very alarming. You may see almost the study says that lake numbers have almost doubled, 53 and 51% in terms of its total number and area globally. So what is important is that this is kind of changing the GLOF hazard situation worldwide. So as these glaciers are losing mass, the meltwater is either contributed to the glacier streams, or they're trapped to form glacial lakes. As the glacier recedes, they thin, and the glacier water is trapped in the frontal moraine. And then, there's with the potential of being breached or causing glacial lake outburst flood in the downstream region. Here is one glacial lake in the state of Himachal Pradesh that shows its growth from 1980s to 2020. You can see that it started as a small supraglacial lake, and you can see its growth over time. And today it is a 2.2 kilometers long glacial lake located in the Western Himalaya. What is very interesting also is to look into how deep can these lakes be. So if you look into this lake, this is the Lower Barun Lake in Nepal, and this lake also has been showing exponential growth over the years from 1975. The lake is quantified to be 112 million cubic meters, and it is one of the deepest known glacial lakes in the Himalaya, with a depth of over 200 meters. Well, to have a perspective of what volumes we are talking about, we're talking about 280 Olympic swimming pools together in one particular glacial lake, and a 49-story building can be submerged into these lakes. So these lakes are quite hazardous with the volume of water they hold. Coming to the population exposed, this is a very interesting study recently where we see that the population exposed in the high mountain Asia is very high, where if you look into India alone, there's 3 million people in India which is exposed to glacial lake outburst floods. Most interestingly, what we see is that in high mountain Asia, the exposure of population it starts at a much higher elevation. If you look into these other mountain ranges like Alps, Andes, we see that within 5 to 10 kilometers from the source, we see exposure of population. Well, what needs attention in GLOF disaster risk reduction are these few important points that I wanted to point out. Is where do we see these hotspots? Where are these early warning systems necessary? What can be an effective approach, whether it's hazard estimation, exposure, vulnerability, or risk? Is it that transboundary GLOF hazard assessments are important? Also, is hazard assessment or early warning system necessary for smaller lakes? What can we learn from the past GLOF events? How do we address low GLOF early warning times? And what is the necessity of having a multi-hazard early warning system? And how accurate are the GLOF models? And the way forward in the GLOF research and effective mitigation. So here is one study that's been published recently where this is the South Lonak Lake in Sikkim, which was which showed tremendous growth over the years from 1990s, and based on the ice thickness modeling, the bed topography modeling, we could see that the glacier has potential to grow in the future, and that allows us to quantify the future GLOF potential of such lakes. And also, as you can see here, this is the present lake outline, and this is the over deepening. The glacial lake is expected to grow in the future by about 1 kilometer. And then as they grow in the future, they're coming closer to these steep slopes, which increases the exposure to mass movements. Also important is to understand what sort of impact waves can lead to different types of GLOFs. For example, if we take the similar lake in a present situation and a future situation of the same lake, we may, considering these stars as the origin of mass movements, in these cases, in the present scenario, where scenario 3, SC3, is going to hit the lake at the periphery at the end of the glacier, where it's in contact with the glacier here, whereas in the future scenario, the same slope will come and hit the center of the lake. So in both the cases, we would expect different wave behaviors of GLOFs. So it's very important to also understand the dynamics, what's going to happen in the future, whether the GLOF energy is going to remain the same or the hazard levels are going to decrease. So we looked into, in a recent paper, we looked into the GLOF hotspots, where we find that in the present situation, we see that Eastern Himalaya, Central Himalaya are the glacial lake outburst flood hotspots. And in the future, where the glaciers are expected to grow, this hotspot is going to shift towards the Karakoram and the Hindu Kush here. And this is based on this trajectory modeling and the exposure to glacial lakes for the present and the future. So where we find out slopes that can trigger, that has potential to trigger mass movements and impact the lake. Well, what can be an effective approach in understanding GLOF risk, whether it's just hazard or its exposure or quantification of vulnerability or entire quantification of the risk, which is a combination of hazard, exposure, and vulnerability. So before that, I'd like to point out to this study here, which was by Adam Emo. Here, this is a word cloud that was analyzed based on 594 GLOF papers, and the size of the word basically is the frequency of occurrence of these words in these 594 analyzed GLOF papers, where we see that we have very less occurrence of concepts of permafrost and climate change, which needs attention in the coming days. It's mostly hazards, but we do not have many situations, many papers where we do not quantify risks. So this is how the risk can be quantified. We have hazards, which actually tells the damage potential of a glacial lake. We have exposure, which is buildings, people, agriculture, or anything that and physical entity that is exposed to the hazard. Quantifying vulnerability, it's tricky, needs a lot of data, but that can be a way forward to quantify risk in a much better way. Well, coming to the last few slides, I wanted to highlight on the transboundary GLOF hazard. Why is it important? A recent study that we conducted shows that there's a lot of lakes located in different countries that can have impact on a neighboring country. Here highlights in the Hindu Kush Karakoram Himalaya, what we see is that glacial lake in China can have an impact in India, where number of transboundary lakes can go up to 80 in numbers. Well, the question also is that whether small glacial lakes needs to be analyzed in terms of its risk. So here is one situation in 2016 where there was a glacial lake outburst flood from this glacial lake, which is called the Bhubaneswar Lake. And if you look into its location, it is just located to this bigger glacial lake, Serenmako, which has a history of GLOF events in 1964, 1981, 2002, and 2016. But the 2016 event, which is from this particular smaller lake, which is the Bhubaneswar Lake, has had impacts which were similar to these previous GLOFs from this bigger lakes. That is because of the terrain here. If you look into the year 2016, there was the Gorkha landslide in 2000, Gorkha earthquake that triggered a lot of landslides along the GLOF path and made a lot of sediments exposed to these glacial lake outburst flood in 2016, which eroded and caused severe damage to the downstream. If you see, this is the landslide density map that was from the Gorkha landslide, Gorkha earthquake, and you can see this is the GLOF path that a lot of sediments and landslide deposits were exposed to the glacial lake outburst flood. With low warning times and multi-hazards, if we look into one of these basins in the Himalayas, where you can have a particular community which is exposed to multiple glacial lakes, and what is important is to have a multi-hazard early warning system or multi-hazard or risk assessments. This is what we see, that hazard assessments from two lakes combined, we have a different hazard and risk maps, which helps us to prepare for the hazards that, multi-hazards that lie in the higher elevation. Well, to look into the performance of the models, we definitely have GLOF models and process chain models that can help us to quantify the impact of GLOF, potential GLOF in the downstream. And this is one comparison to show how the GLOF model behaved and what a real event looked like. This is from the recent 2023 Glacier Lake outburst flood from South Lonak. You can see the GLOF path here. And the inundation, which was modeled in 2019. And this is what happened in 2023. You can see the model more or less was replicated in the real event. And of course, there is GLOF models can help us identify the exposed infrastructure and population, but it is also important that, erosion and deposition is needed to be taken into account. Well, the last couple of slides where I'd like to just show you how can GLOF risk be reduced. Here's one paper where we showed the impact of artificial lake lowering and its impact downstream. So if you see here, this is the present lake, and in 10-meter lowering of the lake, there is 50% reduction in the volume. Whereas in 30% lowering of the lake, we have 79% reduction in the volume. Whereas if you look into the exposure downstream, we see that as the lake is lowered by 10 meters and 30 meters, we see that the settlement, which is located 10 kilometers downstream, has less exposure or no exposure. So this can be one potential measure of reducing GLOF risk. Well, that's not the only benefit we have. We can use these lake lowering water to generate electricity. This is one example from Nepal where electricity is generated for 120 households from water drained out from a glacial lake. Well, there has been confusion about methodologies. There's been several methodologies around the globe, but there are also documents available where that gives you standard basic methodology that can help you to quantify GLOF risks and hazard. Well, thank you. Sorry for the extended talk.
That's fine. Thank you very much. That was very interesting. And I must admit, I hadn't realized the complexity of trying to anticipate the dangers of GLOFs. But very interesting to see the research that you've done. Thank you very much. There are some questions in the